Good morning, everyone. Today we are going to dive into core foundation of how data moves across the world. From the tiny bits is traveling through the wires to the massive wireless networking powering 5G and Wi-Fi. This presentation covers the famous OSI and TCPI models, signal and modulation, multiplexing, and antennas. By the end, you will understand exactly how your phone, laptop, and entire internet devices actually work together. So let's start. What is the data communication and networking? These are four concepts showing data communication and networking, such as networking architecture models, signals, modulation and multiplexing, and antennas. In networking, the OSI and TCPI models provide structured layer to organize global communication functions. Information travel through analogs, digital signals as a basic transformation medium. And modulation modify carrier waves to the encoding data while multiplexing allow multiple streams to share channel efficiently. Antenna convert electrical signal into electromagnetic waves, enabling wireless communication over long distance, forming the core of modern networks. Now we are going to talk about the OSI 7-layer model. There are 7 layers in there. Uh, what those are: physical, data link, network, transport, session, presentation, and application layers. If you think about the OSI model, is a blueprint for network communication. In the created in 1984, they still used today as a teaching and troubleshooting tool. Each layer has specific jobs, and only talk the layer directly about the and below it. Think of it seven layers in flow building. Data starts at the top in the application and travel down to the physical layers to the send over the wire. On the receiving side, it's climb back. This layer approach makes network modular easy to fix. Now we are going to talk about TCP/IP model versus OSI model. There are four models: link protocols, internet protocols, transport protocols, and the application protocols. While OSI is theoretically has in this TCP/IP model, the real-world protocol suits the power the entire internet. It's only 4 layers because it's combined some OSI layers for simplification. Notice how bottom link layer handle both physical and data link function, and the top application layer combine session, presentation, and application. Those 3 layers. Almost every device you use today follow TCP/IP protocols. It's the actual language of the internet. Now we are going to talk about key protocols in TCP and IP. There are 3 protocols: transport layer protocols, network layer protocols, and data link protocols. Let's look at the most important protocols in each layer. In transport layer, the TCP is the reliable one. It makes sure every packet arrives in the order, like registered mail. UDP is a faster but unreliable, perfect for video calls, gaming, where speed matters more than perfection. At the networking layer, IP route packets, ICMP reports errors, ARP finds MAC addresses. Data link uses Ethernet on in offices, triple P for dial-up, Wi-Fi everywhere else. These protocols work together every time you load a web page. Now we are going to talk about the crucial concept regarding the data versus signal. What is the data? Data is the raw information expressed as a bit or byte but cannot travel through any media. What is the signal? Signal is a physical representation like electrical, optical, or electromagnetic wave that carries the data from the media, from the any media. Data is actual information that ones and zeros in your computer understand. But to travel over the cable or any air or any media, you must convert the data into signals like electrical, optical, or electromagnetic wave. The signal is what physically moves through the media. What you got the data and it's converted to the signal and it moves through the any media. Understand the difference help us to see why we need a modulation and why noise can corrupt our data. Now we are going to talk about the characteristics of sinusoidal signal. These are the concept that is using the for sinusoidal signals: amplitude and signal strength, frequency and cycles, phase and signal position, period and wavelength. The most communication signals are based on sine waves. As like this, we can see that in the image, this is how signals are moving. The amplitude is the height. The stronger signal mean louder sound or brighter light. Frequency tell us how many cycles per second hertz. Phase is the starting position of the wave. The period is time of one cycle and the wavelength is the physical distance of the one cycle in the medium. These five characteristics complete the describe any sinusoidal signals and are used in all modulation techniques. Now we are going to talk about more on the signals. There are two types, analog and digital. What is analog? Analog signals are continuous. Think of human voice or old radio. They are smooth but very sensitive to noise. Digital signals are discrete steps of ones and zeros and ones, much more resistant to noise and easy to regenerate, store and process with the computer. That's why entire modern world converted from analog to digital, better quality, less interference and perfect for computers. Now we are talk about the transmission impairment. There are three concepts: noise interference, signal attenuation, and signal distortion. Every single faces three enemies during the transmission. Noise is unwanted random energy added to the signal. Attenuation is a natural loss of strength over distance. That's why we need amplifiers. Distortion changes the shape of signal, especially in long cable or wireless multipath environments. Understanding this helps engineers to design a better error correction and stronger signal. Now we are going to talk about digital signal errors. Even digital signal can get corrupted. A signal bit flip turn 0 into 1 or vice versa, which can ruin an entire packet. That's why we use use error detection methods like PIDS, CRC, and checksums. In advanced systems, we even correct errors on the fly. Without these techniques, the internet would be completely unreliable. Now you can see that one original signal is going how it's going, but when it comes to error, it's showing different path. You can see the diagram. Now we are going to talk about decibel. Decibel is the standard way engineers measure signal strength and gain. The formula is, you can see as I mentioned in the formula, is 10 log 10 P2 slash P1. When power doubles, we get plus 3 dB, a very common reference. Wi-Fi signal strength is shown in dBm. Minus 50 dB is excellent, and minus 90 dBm is a barely unusable. Understanding dB helps us to quickly compare signal quality in real network. So as you can see, there is I provide the image. We are going to talk about modulation. Modulation is what? Modulation is the magic that lets us send data over long distance. We take high frequency carrier wave and change its amplitude, frequency or phase according to our data. So amplitude, frequency and phase is the three data types in the modulation sequence. This is crucial because baseband signals, raw data, cannot travel far. So in that time, modulation allowed to multiplexing matches media bandwidth, enabling wireless communication. Without it, your phone could not connect to the cell tower 2 kilometers away. So within a 2 kilometers, you can access any data, but more than 2 kilometers, you need to work with the modulation. That's how the modulation is working. Now we are going to talk about digital module techniques. There are four concepts. One is ASK. ASK is amplitude shift keying. FSK. FSK is a frequency shift keying. PSK. PSK is a phase shift keying. QAM, quadrat amplitude modulation. Here those are the four module schemas. ASK is a simple but noise sensitive. FSK is a RODUS and used in older modems. PSK is a more efficient and the common in satellites. PSK we use for satellites, mostly using in the satellites. It's a more clear nowadays. QAM combine amplitudes and phase. So as we talked about earlier, it's working with the amplitude and the phase. That's what give us a super high data rates in Wi-Fi 6 and 5G or 4G. The more complex and modulation, higher the speed, but also more sensitive to noise. Now we are going to talk about multiplexing technique. There are four concepts: FDM, frequency division multiplexing; TDM, time division multiplexing; WDM, wavelength division multiplexing; and CDM, code division multiplexing. Multiplexing lets multiple users share the same channel efficiently. FDM divide frequency like different radio station. TDM divides time each user get done. WDM for optical fibers using light wavelength, and CDM which separates signals with the unique codes. These are the essential in telephony, internet, cable TV and wireless network to handle high data volume without interference. Now we are going to talk about multiple access method. There are four access method: FDMA, frequency division multiple access, TDMA time division multiple access, CDMA code division multiple access, CSMA/CA carrier sense multiple access with a collision avoidance. Multiple access is a multiplexing for wireless users. FDMA gives each user their own frequency band. TDMA gives a time slot. CDMA is transmitted simultaneously using the unique spreading codes. And CSMA/CA is used in Wi-Fi where devices listen to before transmitting and use back off to avoid collision. Now we are going to talk about duplexing. There is a major duplexing method. One is FDD, another one is TDD. What is FDD? Frequency division duplex. TDD, time division duplex. What is FDD? Duplexing decide how uplink and downlink share resources. FDD uses two separate frequencies. Traditional cellular networks allow it because there is no waiting. TDD use same frequency but alternates time, cheaper spectrums and used in Wi-Fi and modern 5G. TDD is more flexible for asymmetric traffic like video streaming. Now we are going to talk about our last lesson regarding the antennas. How many types antenna have? Antenna have two types. Dipole is a simple, parabolic is a directional. There is a three characteristics: gain, polarization, and bandwidth. And the antenna is a convert electrical signals to electronic magnetic waves, transmitted or vice versa received. You are getting transmitted, and vice versa you can receive. And you can see the antenna diagram in the right side top corner. Antenna, the omnidirectional antenna and directional antenna. In the directional antenna, they're divided to sections: traditional directional antenna versus smart antenna. And below image, you can see that one. Smart antenna is divided to three sections: switch beam, steerable signal beam, and adaptive array. And there is types of antennas. Those are dipole, Yagi-Uda, parabolic, loop, and periodic, helical, patch, monopole. These we now going to end up our session. What we talk? What is the key point we talk about here? Those are OSI layer approach, TCP/IP model is how real world is using, and signal modulation, multiplexing, and long distance communication, how is possible it work, and the modern wireless, OFDMA, OFDTD, and power 4G, 5G. We talk about those things. We're going to end up the session. Thank you so much for your attention. Any question if you need, I can answer questions regarding this topic. So I hope everyone got understand the session, the clear picture of how data actually travels and one device to another device, how you are when you are going to call with someone, how it's received to him, and how you got to receive, how you send the data. So how 4G, 5G, Wi-Fi, how it's working in the real world. So I think we can end up our lesson. Thank you.